Hi, my name is Faraiba binti Rahim and my matrix number is 200928. Just to clarify, Jengyu and I are supposed to do the video together, but since the potent video he made cannot be saved, then we need to divide our presentation into two parts. So, he already posted his video and I've provided the link in the caption. His video contains introduction of the sequence and series and also two sample problems. So, go check it out first before you continue watching my video. I've prepared 3 sample problems in my part of presentation. The problems involve the concept of sequence and series that we have learned in our class. All of the problems relate to engineering field. To summarize, it consists of aromatic series, geometric series, and also infinite geometric series. Without further ado, let's take a look at the first problem. An object falls for 3.45 feet in the first second after it being dropped on the moon. Each second it falls 6.50 feet farther than in the previous second. How far would the object fall in the first 10 seconds after being dropped? From the problem, we know that this is aromatic series problem. Next, we identify what is A, D, and also N. Given here is the sum of an aromatic series formula, which is Sn equals to n over 2 times with 2a plus n minus 1d. By substituting the values, we get the final answer, which is 327. Problem 2. A hot air balloon rises 80 feet in its first minute of flight. In each succeeding minute, it rises only 70% as far as it did during the preceding minute. What is the final height of the balloon after 8 minutes? If the balloon rises indefinitely, what is the maximum height attainable? For the second problem, we also know that it is a geometric series problem. First, we state the geometric sequence in the first 5 minutes. Then, we identify what is A, R, and N. For the first question, we use the sum of geometric series formula, which is Sn equals to A times with 1 minus r to the power of n divided by 1 minus r. After we put in the value, we get 251.29 feet. As for the second question, we use the sum of infinite geometric series formula to get the attainable maximum height. We just input the value and get 266.67 feet as the answer. Problem 3. A vacuum pump removes 35% air from a container with each stroke of its piston. What percent of the original air remains after 4 strokes of the piston? For the third problem, it's a bit tricky, but it's actually not that hard if you're able to know what equation to be used. And for this problem, we are using the 1 minus r to the power of n. From the problem itself, we know that n is equals to 4 and r is equals to 35%. After substituting the value, we get 17.85% of the original air that remains in the container. As a conclusion, sequence and series are useful to predict the possibility of any event, to design structures, and also to analyze real-life situations. These are just few examples on how this topic can be useful of. But for your information, sequence and series can be applied in almost all aspects of our lives. We just have to analyze how it can be used, and by having the knowledge about this particular topic, it can give us a different perspective on how things happen in our life. In general, if you study this, you can take any personal and professional decision logically, which will give immense benefit to you. Plus, it also helps you to face challenges successfully. Okay, that's all from me. Thank you.